Live, sir. We are live.
Presentation.
Sir, आप खाली stop presentation कर दियंतु खाली वीडियो टा ऑन करके.
Stop presentation. Just stop presentation, sir.
Yes, fine. Continue, sir.
Okay. Okay. So I am. Good morning, sir. Good morning, dear participants. Today with us, Dr. Anil Kumar Mishra. He is the Associate Professor, Department of Civil Engineering, IIT Guwahati. Actually, due to some problem, we have contacted another teacher actually, and from last evening we contacted with him, and he also accepted our invitation to give a talk. So thank you very much, sir, for helping us. And regarding his deep curriculum, right, he has completed BTech in Civil Engineering from IGIT Sarang and MTech from IISc Bangalore, and obtained PhD degree from Kyushu University, Japan. And his research interest basically geo-environmental engineering, and he has received many awards. Some awards are I am mentioning. In 2019, JASO Fellowship to carry out research work in Kyushu University, Japan. Also, he received Students Award of Excellence in recognition of outstanding research in the geotechnical engineering by Japanese Geotechnical Society, and he has also published many papers in international journals and reputed journals. So I welcome Dr. Anil Kumar Mishra, sir, to deliver a talk in research and practices in civil engineering, which is organized by Department of Civil Engineering and IGIT Sarang. And thank you, sir. Now you may proceed.
Okay. Good morning, everyone. So I am Dr. Anil Kumar Mishra, and today I will be delivering a talk on geo-environmental engineering. So I'll start my slide.
Yes,
so today I will be presenting a topic called contamination of geo-environment, its determination and remediation. So this is a part of geo-environmental engineering and is the basic things which I'll be talking in this presentation. So this topic, this presentation has several contents, which includes introduction, source of contamination, types of contaminants, contamination process, contamination detection system, remediation technology, conclusion, and further study. So before that, you might be wondering what is geo-environmental engineering, because you might have heard about geotechnical engineering, environmental engineering, structural engineering, but what is exactly geo-environmental engineering? Geo-environmental engineering actually an interdisciplinary subjects consisting of environment as well as geotechnology part. So for example, in this picture you can see this is our world. Okay, so this is atmosphere, the biosphere, where we live, the plant grows. The other part is soil, where the plant grows and which is below our feet. The other part is called water, which is above the ground or maybe inside the ground. Okay, inside the soil. So anything which has been contaminated will also affect the other parts. For example, if there's a rainfall occurs and which contains suppose acid rain, so in that case our water as well as soil as well as biosphere will get affected. So in environmental geotechnology, it will be dealing with the effect of contaminants on environment as well as geotechnology. So how to solve these problems using environmental engineering and geotechnical engineering is called as environmental geotechnology. So exactly what is the need of this one? So right now with the industrialization, nuclear facilities, population increase, so it creates a lot of problems, including a lot of waste and lot of toxic materials. And because of all these toxic materials and the waste, so this leads to change in our atmosphere. And also this, when this leachate or this toxic chemicals when goes into our water system, then it contaminates the water source, from which we take our water, and by then it will affect our health. So exactly how this happens. Say for example, the starting point is a pollutant. So pollutant is a source of all the problems. So pollutants, either it can be disposed accidentally. So when it's disposed accidentally, it can contaminate soil, water, air, or it can be uptake by our biosphere, that means plant and animals. So again, the plant and animals can also take this water or air or soil which is contaminated by pollutant. So again, when these animals or plant, when we consume this one, or when we take this water or air, when the human beings gets contaminated. Contaminated means they fell ill. Okay, so exactly how big is this problem? So this is our human, this is our body. You can see the air pollution. Air pollution has different particulates matter here, like CO or CO2, NOx. So these are ozone. So all this affects our internal organs. Say water pollution. Water means a lot of bacteria will be there, parasites will be there, chemicals will be there, and that will create a lot of problems to our intestine. Or it also can causes cancer, skin irritation. Similarly, the soil pollution. Soil pollution generally is carried out by the pollutant as well as by pesticides. So when these pollutants or pesticides, when the plant or the cattle they use this one, then it will indirectly come to us and it will create a problems in our intestine. So these are the different kind of problems which we may face due to because of exposure to different chemicals. So you can see all parts of the body are gets affected because of the different chemicals present in soil or water or air. So these are the some cases which actually occurred. So the first example was the Minamata disease, which occurred in Japan, and it was going unnoticed from 1932 to 1968. So people were exactly not knowing what was the causes, what was the thing which is causing the problem. So exactly this problem happened because of the release of methyl mercury, and this methyl mercury was discharged into water stream, and when the people on the downstream side took this water, they fell ill. So like this kind of problems happen. So it causes mental problems, it causes the problem with the bones. So finally, after 36 years, it was noticed that this is caused by the methyl mercury, which was being released by one plant, by factory in Japan, in the city of Minamata. So from that Minamata, the name of the city, the disease name came Minamata disease. And because of this Minamata disease, 1784 people died, and right now many people are also suffering from this disease. Another example is our Bhopal gas disaster. So this is a typical problem of the air pollution. So you might be knowing that in 1984, because of the release of toxic gas, thousands of people died. So another problem it was noticed in Canada. So in this problem what happened, some fox with limbs broken, or limbs were this kind of problems happened in Canada due to the water pollution. So this is our environment. You can see this is an industry which releases toxic gas, and because when we take this toxic gas, when the plant takes all this toxic gas, then it gets contaminated. When there is a rainfall, this can create acid rain, and when the acid rains goes to the atmosphere, goes to the groundwater. So the groundwater source get contaminated. When this groundwater source we take as a drinking water, then we also get problem. So generally talking about the source of contamination, we have different kind of sources. like mining, painting, forestry, auto, municipal solid waste, agriculture. These are the typical examples of few source of contamination. So this is in a picture I can summarize here. So these are the different source of contamination. This is a landfill site. The landfill site produces leachate. So leachate, when goes to the groundwater, it's contaminated. Similarly, you can see land spreading. So when there is a problem with the pesticides or heavy metals, so pesticides, heavy metals, so it will contaminate. It will contaminate our ground resource. Similarly, septic tank, when there is a leakage from the septic tank, it will contaminate our ground resource. So these are some sources of the contamination of the groundwater. Another example is acid rock drainage, which you might have seen in mining area. So in acid rock drainage, so acids are formed because of some chemical reactions, and when these acids goes into water resource, it will contaminate our groundwater resource. So similarly, other examples are surface impoundments like ponds, lagoons, pits, and also another example is hydrocarbon leakage taking place from your gas station, like a petrol pump. So these are the storage tank. When there is a leakage occurs, so those petrol or diesel goes into the water resource here, and that contaminate our groundwater resource. Another example is your landfill. So this is an example of a dump site where we generally throw our garbage. So those garbage produce chemicals which is known as leachates. When this leachates goes and contaminate our groundwater resource, so water gets contaminated. When we drink that water, then we feel sick. So this is example of a landfill site. You can see a lot of waste, and those waste produce leachate. Those leachates can migrate through these barrier layers and contaminate our groundwater resource. Okay. Next is what kind of contaminants we generally face. So generally we have two different kind of contaminants. One is called inorganic. So inorganic means metals, heavy metals, major ions, and nutrients. Organic means we have some petroleum, hydrocarbons, and chlorophenols. So typical example of metals ions are silver, mercury, cadmium, zinc, copper, lead, chromium, arsenic. So these are different metals or heavy metals generally present in our contaminants, which creates a problem to the environment. So the source of these heavy metals may be mining and smelting operations, mining and tailing ponds, metal plating operations, paintings operation, pulp mills, wood treatment. So these are the different sources from where these metals can gets out and contaminate our groundwater resource. Similarly, major ions are chloride, nitrate, sulfate, bicarbonate, ammonia, phosphate, sodium. So these are the different nutrients or major ions. Generally, these are found in septic fields, landfills, fertilizers. Then petroleum hydrocarbons, we do gasoline, diesel, motor oil, bunker oil. So the sources are like storage tanks, underground storage tanks, gas stations, refineries, railway yards. So these are the different kind of another thing is pesticides like DDT, chloroden, linden. All these are the sources from the agriculture area. Disposal sites containing pesticides, manufacturers, airfield, roadway, railways. So these are different pesticides which can harm the environment. So generally, how this contaminants takes place. So suppose this is our source from where the contaminants release into atmosphere. So these are the contaminants. The contaminants then move into our environment through soil. These are the soil, and some of the contaminants are get absorbed by the soil. So you can see the yellow one is the soil particles before the contamination. The red soil particles are the soil particles which are get contaminated by contaminants. So you can see it's not like all the contaminants all are get absorbed by the clay. So depending on its cation exchange capacity and surface area, how much contaminants can get absorbed depends. The rest amount will again move through the soil and will go into water resource. So these are the process by which the contamination takes place. Now, how to detect whether there is a contamination or not? This is a new technique. Apart from other techniques, I will be discussing about this one. This is called partitioning tracer method. Suppose this is a petroleum tank or source of contamination, and these are contaminant. So since it will be underground, we cannot see in the naked eye from the top. So that's why we have to go for this partitioning tracer method. So these are in which we have to inject some chemicals known as tracer. So when the tracer will react with these contaminants, the red ones, it will slow down. But whereas if it's not react, it can directly flow from this. Now this tracer will be extracted from this side, and by knowing this, how much has been absorbed by these contaminants, we can determine how much soil has been contaminated with this contaminants. By knowing how much how much amount of tracer has been absorbed or partitioned by these contaminants. Similarly, the other techniques are there. One is called tracer method. See, most important thing is all this contamination takes place below the soil. So that's why we cannot see. So therefore we have to go for indirect method. So in tracer method, what happens? A tracer will be injected like this one, and it will be recorded here. If the tracer is coming out from this side, so that means there will be some leakage is happening. So this is an example of a landfill site, and these are the barrier material. The barrier material is provided to arrest all these contaminants within it, or that means not allow the contaminant to pass through this material. If there is a leakage, then contaminant will pass through. So when we inject a contaminant, we inject a tracer, that tracer will also come out along with these chemicals, and which will be recorded here. So if we found any trace of this tracer material, that means there is a leakage happening around this barrier material. Similarly, geomembrane monitoring system is there, and recently another method is called grid net electrical circuit method is there. In this system, a circuit of electric grid will be generally installed below the landfill site, and when there is a leakage occurs, so you can see a rise in a peak value of electrical conductivity. So this conductivity, there's a rise in the peak, will tell you about how much has been how much contaminant has been released, and what is the point of this one. You can see there are two different peaks, so that telling that exactly there is a leakage occurs in this point and at this point. So once you know there is a leakage, then we need to treat. It's similar to our treatment of disease. First, we need to see whether there is a disease or not. If there is a disease, by how we have to know? We have to do some test. So if we found some disease is there, then we have to go for the treatment. So this is called contamination remediation technologies. So before starting our contamination techniques, we need to be sure that what are the different contaminant and how these are contaminating our ground resource. So first one is sources originating on the ground surface. The contaminant can originate on the ground surface. For example, infiltration of the contaminated surface water, accidental spill of some chemicals, then spreading of fertilizer and pesticides, disposal of sewage and water treatment plant sludge. Similarly, some of the sources can be below groundwater, below soil and above water table, like waste disposal in excavation, landfill, leakage from underground storage tank, septic tanks. And the third category is some sources which are present below the water table, like deep well injection mines, waste disposal in wet excavations. So these are the three different scenarios in which the contaminant can be released into groundwater resource. So when we go for the remediation technique, so there are different steps. So first one is site characterization. In the first step, the contaminated site will be thoroughly checked with to know what kind of contaminants are present, whether there is in physical form or not, what is the source of contaminants, and what are the boundaries, and whether these contaminants are moving or are stationary. So this initial information we can get from this site characterization. So for this method, we have to use different techniques known as ground penetrating radar or GPR, current resistivity method, seismic method, pumping well methods, by which we will know exactly the site has been contaminated or not. Then we have to go for the risk assessment. Remember that the cost of treatment of the soil or contaminated soil is very high. So therefore we have to go for the risk assessment to know whether this contaminant can have any detrimental effect on human health or not. So in risk assessment, we have to see whether there is any potential risk posed by the contamination on human health. If it's not, then we can leave it. Or if there is a risk involved, then we have to treat the soil or water. Once we know that we have to treat the soil, then next step will be what will be the treatment method. So in remedial action, we need to see what kind of treatment method we have to adopt. So the remediation process can be in situ or ex situ. So in situ waste treatment containment, so the two systems, one is called passive system and another one is called active system. In passive system, what happens, we will enclose the contaminant with some barrier walls. So those barrier walls will be in the form of vertical barriers or bottom barriers and surface cap. So main objective of this system is to not allow the contaminant to move further. So this is called passive system. In active system, what happens, we have to lower the groundwater such that the groundwater will not touch the contaminant, because if the groundwater is allowed to mix with the contaminant, then contaminant will move from one place to another place through the water. So in active system, we will not allow the groundwater to be in touch with the contaminant. How we can do it? We can do it by lowering the groundwater by different techniques. So I will go into details, but first I will discuss about the passive system. In passive system, we have different components. First one is a vertical barrier. This is a vertical barrier. As the name suggests, this is a wall constructed in the vertical direction. So these vertical walls will not allow this water to react with the waste material present inside. You can see this is a vertical wall. Suppose in some cases the vertical wall can go directly up to this rock strata. In some cases, when the contaminant is floating on the water and not dissolve one, then in that case you can dig this wall up to certain depth below the water table. You don't need to go until full depth because the contaminant will be present only on the surface. So depending on what kind of contaminants, either it can be dig into the rock strata or it can go up to certain depth below the water table. Sometimes we provide this vertical wall all around the waste. So this is called as circumferential configuration or circumferential vertical wall. So in the circumferential vertical wall, the waste material will be enclosed by a circular vertical wall. So we can also provide this one as an up gradient. In up gradient, we have to provide a vertical wall on the upstream side so that water will not allow to react with this. In downstream side, also we can provide which is called as down gradient barrier, like this one. In this case, the groundwater is allowed to react with the waste, but this contaminated waste will not be allowed to go beyond this one. And there will be extraction wells present here by which we can take out the contaminated water. So depending on whether it's upstream side or downstream side, it can be called as up gradient or down gradient barrier. So generally, different materials are used for construction of the vertical walls. So one is called compacted clay barrier or slurry trench barrier, grouted barriers, steel sheet pipes are different common examples of vertical wall. Now the water, when we provide a vertical barrier wall, still the waste can also migrate through the bottom. So in order to prevent the movement of this waste through the bottom, we have to provide a sill material at the bottom, which is known as bottom barriers. And the next thing is the surface cap or cover. In surface cap, suppose if there is a rainfall occurs, so in that case the water will migrate through the soil and can react with the waste. So if we provide a cap over here, so that will prevent the rainwater to come in contact with the waste material. So the surface cap is generally provided at the top of the waste material. Another technique is called ground freezing technique. So this is one of the latest technology in which several freezing tubes will be installed all around your contaminant plume, and then it will be the soil around this contaminant will be frozen. Once the soil is frozen, this contaminated plume will not able to move. And this is one of the very expensive technique, and also depending on the country and climate, it can be used. Next one is your active system. In active system, we have to lower the groundwater table such that the groundwater will not able to react with this contaminated soil. So how to do that? We have to dig some well and we have to take out water. So this is, you can see different wells are there. So when you start pumping out the water from this groundwater, so the water table will fall below and it will pass below this contaminated site. So here we are just manipulating the groundwater table such that the groundwater will not react with the waste containment waste and further move into your downstream side. So this can be achieved by groundwater pumping system. So first technique of active system is your groundwater pumping system, in which wells will be injected or well will be inserted, and then the water will be extracted using those wells. When we take out the water, so water table depth will go down and it will go below this contaminated site. Another one is subsurface drain. So we can also provide drain below the contaminated surface, or not below, maybe on the side also. So in these drains, the water will pass through the drains and can be extracted using this discharge well. And when the water pass through this, the water table lowers down and it will pass below your contaminated soil. You can see over here, this is your drainage area and this is your contaminant, this is in plan. So when we put some drainage layer like this, the water table goes on decreasing and it will pass below this contaminated site, so that it will not react with this contaminated soil and then it will not get contaminated. Next is this is a prevention technique, so that the soil or the contaminant will not move further and it will stay in a place. Then we have to go for the treatment. So this is called the remediation technology. So these remediation techniques can be in situ or ex situ. In situ means the soil will be treated, or soil or contaminated water will be treated in the site itself. In ex situ techniques, the soil or the water will be excavated or will be taken out using wells, and then it will be treated somewhere else. So there are different techniques which are known as soil vapor extraction, soil washing, stabilization and solidification, electrokinetic remediation, bioremediation, phytoremediation. So I will go one by one. The first one is soil vapor extraction method. In this method is generally used for volatile organic compound and motor fuels. Suppose this is your contaminated soil, contaminated with organic contaminants, say for example naphtha. And then first thing is we need to dig few wells. So one well will be within this contaminated zone area and few will be outside this. Now here in this stream, in this well, we have to inject steam of high temperature. Steam, then what happens? Then again what we'll do is we have to extract, we have to create a negative pressure all around. So because of this steams will move towards this water vapor, towards this well. And when these steams will move along this one, the naphtha or the organic contaminated can get vaporized and can move along with it and can be extracted using this extraction well. So this is called soil vapor extraction method. So this method is very easy one and very economical, and the equipments required for this method is very cheap, and also it's effective in treating both dissolved and free phase contaminants. But again it has certain disadvantages, like the contaminant removal is very slow at the beginning, very fast at the beginning, but slows down with time. And when the soil is very low permeable like clay, all these things, this method will be very ineffective. And also this method is applicable for unsaturated soil. When the soil is saturated or more amount of water is present, the temperature of the vapor will get decreased and the effectiveness of this method will also reduced. Next is soil washing technique. In soil washing technique, the soil will be washed with some chemicals. As I told you earlier, the treatment method is very expensive. Now, what happens when there is a contaminant present? The contaminant will attach more strongly with the clay particles or silt particles, mostly with the clay particles because of its negative charge. Now, if we use, and the amount of clay present in a soil may be sometimes limited, and if you use the same techniques for entire soil to remove the contaminant, then the cost of treatment will be very high. So in this case, in this method, what we have to do is we have to remove the large particles from the fine particles. So once the fine particles are removed, they can be treated separately, and by that the volume of the contaminated soil will get reduced, and so the cost gets reduced. So there are different techniques for this. In the first technique, steps, the contaminated soil will be screened to remove an oversized debris, and then once these larger particles are removed, then the soil will be passed to a soil scrubbing unit where it will be allowed to react with certain chemicals, or it will be washed with certain chemicals. So after this process, what happens? The large particles will be removed, large particles like clean sand and gravels will be removed, and then this can be again sent to the site. Then again we will find some clean silt and clay, and also we will find some contaminated soil. So this contaminated soil or material will further be treated. Now once we washed the soil with some chemicals, we will find some wash water. So again we will check whether this wash water have different additives. If yes, then it has to be treated at the offsite. If no, then further we can recycle this waste, and you can use this one to further treat another soil So these are the different, as I told you, different methods. So this is the first step. In the second step, the larger particles will be removed, larger impurities over like tire or plastic waste has to be removed. Then it has to be washed with high pressure water containing chemicals. Then it will be aerated, and then we have to remove this contaminated soil, and then we have to take out the contaminated water. Then we have to allow the precipitation of this one, and then we have to go for, depending on the concentration of the contaminant, again either we have to go to this or we can go to the site. So this is a ex situ technique. In this method, the soil will be excavated and treated at different locations. This is an example of this soil washing technique. You can see in the first step, the soil was first taken out and it's being screened over here. It's being screened to remove any large particles. Then the fine particles will be then cleaned using some chemicals. These are the treated soil. So the advantage of this method is it can remove the volume of the soil up to 90%. So that means the cost also gets reduced. And also this allows the contaminated soil to be excavated and treated on site itself. And also it can remove the organic as well as inorganic contaminants. The disadvantage is it is ineffective for soil containing 30 to 50% of silt, clay or organic matter. Because more is the amount of organic or clay matter, the cost it will be ineffective. Because here we are only removing the large particles such that the cost will get reduced. And relatively expensive this one. And also it has another problem that we have to deal with the wash water, because we have to throw it, and that will create another problem. Next is stabilization and solidification. In fact, this is not a remediation technique. This is only to stabilize the soil or the solidify the soil such that it will not move further, and then we can go for treatment method. So in this process, the soil will be immobilized or encapsulated using different additives like chemicals, and then arrest those contaminant at the soil. So it has like stabilization. That means we have to add some chemicals to convert this contaminant into less soluble, or less mobile, or less toxic. Or we can make it to solidify by adding some chemicals like cement and make it to more solid particles. As I told you, this technology neither removes the contaminants from the soil, such as washing, nor degrade the contaminants, such as bioremediation. It only eliminates the mobility of the contaminants. So it can be in situ method or it can be ex situ method. In ex situ method, the soil will be excavated, then it will be mixed with some reagent, and then it will be allowed to cure, and then it will be backfilled at the site. In situ methods, injection wells will be digged and some chemicals will be injected such that the contamination will be solidified. The advantage of this method is very low cost, and it will be applicable to a wide variety of contaminants, applicable to different kind of soils, and the equipments are very simple and easily available. The rate of treatment is also high, but disadvantage is it will neither remove or destroy the contaminants. And also when we add some chemicals to it, the volume of the contaminants will also get increased. And also what happens in the future, we don't know. So these are the certain disadvantages of this method. So it can be carried out using cement, pozzolanic materials, thermoplastic materials, organic polymerization materials. So these are the certain materials which we can use to solidify or stabilize our contaminants. The another method is called electrokinetic remediation. In this process, one electrical potential will be applied, and because of this, the contaminants will move towards the electrodes. You can see this is a contaminated soil, and these are our electrodes. When we apply some electrical potential, the contaminant will move towards the opposite charge towards here. Say, for example, if this is your anode, this is positive charge, then the negative charged contaminant will move towards here, and here similarly the positive charged cations will move, and then it will be extracted using some techniques. So this is applicable to low permeable soil in heterogeneous soils, and also it's applicable for a wide range of contaminants. It can be in situ, ex situ, and it's very less expensive and can be used for both saturated and unsaturated soil. However, if there's a buried material inside the soil, then there may be problem with a short circuit. And also, if there is an acidic condition exists in the soil, then the electrodes may get deteriorate. Then another technique is called thermal desorption. In thermal desorption, the contaminated soil will be heated between 200 to 1000 degree Fahrenheit. So when we heat those contaminated soil, the volatile contaminant will be removed from this soil. So it's a very simple technique. Rate of treatment is also high and is mostly used for treating volatile organic compound, and low temperature is used and requires less fuel, and treated soil can be redeposited at site. But problem with this one is, if there is a water present, then we have to remove the water first, because the presence of the water will increase the cost. Similarly, if the clay and silt soils are present, then the reaction time will also increase. And also it's only applicable for organic volatile contaminant, not for heavy metals which are generally present in the soil. Another method is called bioremediation. In bioremediation methods, microbes are used to remove the contaminant from the soil. So we have to inject some microbes to the soil, and we have to supply some oxygen, moisture and nutrients such that it can easily react with the soil and can fast the reaction. So in this process of bioremediation, if we add some natural process, the process of bioremediation, in which enhancement of the natural process by adding microorganism to the soil is known as bioaugmentation, and or supply oxygen, moisture and nutrients are required, then it's called biostimulation. So it can be of aerobic bioremediation, it can be anaerobic bioremediation. So in this example, you can see this is a contaminated oil which has to be removed by this microorganism. So what will happen? This microorganism will eat this oil, and then it will be digest that one, and then it will release as carbon dioxide and water to the atmosphere. So in bioremediation, the complete removal of organic compound takes place, and requirement of mechanical equipment is also minimum. It's very less expensive, but it has the problem is it will be very sensitive to the environmental condition, and extensive monitoring is required. The process is very slow and also can take long time. Another method is called phytoremediation. In the phytoremediation method, the plant will be used to treat the soil. So that is called phytoremediation. In the the contaminant's fate is determined by plant's capacity to break down and absorb the organic chemicals by plant metabolic process, which is called as phytodegradation, or it can accumulate those inorganic chemicals in the plant tissue which is called as phytoaccumulation. So these are the two processes by which the plant can remove the contaminant from the soil. In phytodegradation, it will absorb this organic chemicals and degrade the contaminants. In phytoaccumulation, it absorbs the inorganic chemicals and store it in their stems or tissue. So these are the different kind of different kind of contaminants which can be removed using your phytoremediation. Examples are explosive, crude oil, oil products, pesticides, heavy metals, radionuclides, and some of the plants like willow, poplar, Indian mustard, sunflower, cabbage are generally used for these methods. So it has different steps. So depending on whether your contaminant is organic or inorganic, the steps are different. But these are the certain steps which takes place. In the first steps of phytostabilization, contaminants are adsorbed and immobilized by the root along with the groundwater. So these are the first steps, and it present in both for organic contaminants and for your inorganic contaminants. The second step is rhizodegradation. In this, the breakdown of the contaminants by microbes present in the soil takes place. So this is happens only for your organic contaminants. For inorganic, it will not be there. The third one is the rhizofiltration, in which the contaminant pass through the root membranes before they are absorbed by the plants. So these are present both for organic as well as inorganic contaminants. Then phytodegradation. In this method, the breakdown of the absorbed contaminants by plant metabolic process takes place. So this presents only for the organic contaminants. The next step is phytoaccumulation, where it will be accumulated, which cannot be degraded. It will be accumulated by plant tissue. So this will be present only for inorganic contaminants. The last step will be phytovolatilization. It will where the release of the water soluble contaminant to the atmosphere takes place. So this occurs both for organic as well as inorganic contaminant. So this method is very cheap and also in situ technique and also very safe. But thing is, it's very slow process and also relatively shallow depth. I mean, the contaminant can be removed up to a shallow depth where up to the root can go. So this is all related with what I discussed is with how to remove the contaminant. Suppose the water is get contaminated, then how to treat that? So in this technique, we have pump and treat method, in which suppose this is a contaminated plume and it's contaminated the water all around. So what we have to do is we have to dig some wells. So depending on what we have, the name of the well also are different. One is called recharge well, second is called extraction well. Okay, so in extraction well, so water will be extracted and it will be treated and then it will be recharged or will be injected into this groundwater. So in this system, the water will be extracted using your extraction well, will be treated at the surface, and then again it will be recharged. So it can remove the contaminant effectively, and it requires simple equipments. The disadvantage is long time period is required, high cost of treating method, and the operational cost and the maintenance cost is very high. Next is in situ flushing. So in this technique, what happens? Some of these wells will be injected, and this injected well will be then some reagent will be injected into the soil, into the water, and this injected chemicals will react with the water and it will get removed from this. So this is called in situ flushing. A flushing solution is pumped into groundwater via the injection well, The solution then flow down gradient through the region of contamination, where it will dissolve. Then it will be taken out. The last method is permeable reactive barrier. So this is called as PRB wall. So in this method, a wall is created made of different materials depending on what kind of contaminant it has. So this is known as a barrier wall. So this barrier wall will allow the contaminated water to pass through, but during this time, the contaminants will be absorbed by the material present in this wall. So once this contaminated plume is pass through this one, the other side, the treated water will come out. So this is kind of magic wall. So this is called as permeable reactive barrier, or PRB. So depending on the chemical present in the groundwater or the contaminants, the wall material may be different. So depending on, suppose if it's organic, then zero valent ions, or this thing is, and there are different types like degradation, sorption, precipitation, degradation technique will be used to remove the contaminant from the groundwater. So the advantage is no pumping or above ground treatment is required. PRB can be effectively modified to treat several different kind of contaminants. The cost is low. The disadvantage is lengthy treatment time compared to other methods, and also sometimes the wall get clogged with time, so that's reduce the effectiveness. And also we have to remove this media and require replacement frequently, so that also causes some problem. So these are a PRB barrier. So the conclusion from this one is the groundwater can be polluted due to the intrusion of the contaminants. The sources are like mining, automobiles, municipal solid waste, heavy industries, and the extent of contamination of the groundwater as well as soil can be determined using different techniques. So once we know what kind of contaminants it has, whether they are movable or immovable, then different techniques will be used. So this is the end of the presentation. Thanks for your patience.
Hello, thank you, sir.
Thanks.
Hello, thank you, sir, for giving a nice presentation. Sir, please stop presentation. Okay. So thank you, sir, for giving a nice presentation. And students have asked some questions. If you permit,
Okay,
sir,
sure.
I want to ask some question on behalf of them. Sir, first question. Actually, which soil washing system is economical, and what are the different parameters considered so that the system will be more economical?
This is the same question.
Yeah, same question.
Which soil?
Which soil washing system is more economical, and what are the parameters?
See, this is I'm giving a method, general method in nutshell. So depending on what kind of contaminant you have, depending on what kind of soil you have, or how much clay content it has, or how much large particles it has, the methods will be different. So it will be difficult to say without knowing what kind of contaminant, what kind of soil type it has. So depending on soil type and contaminants, the method will be different and the cost will be different. But mostly, if the clay content or silt content is more, this method will not be applicable. Hello?
Okay, thank you, sir. Okay, sir. Hello.
Huh,
Hello,
yeah.
audible, sir?
Yeah, it's audible.
Okay, sir. Sir, bioremedy method will be equally applicable for soil containing heavy metals?
Yes, yes. Generally, soil containing heavy metals can be decontaminated using bioremediation. You are talking bioremediation?
Yeah.
No. Bioremediation is mostly for organic contaminant.
Okay.
Okay, because the bio means organisms. So the organisms only eat organic materials. So therefore, it will be mostly used for organic contaminants. Phytoremediation can be
Okay,
used
sir.
for both organic as well as your heavy metals.
Okay. Sir, what are the different parameters affecting selection of a particular remediation technique? What are the parameters actually?
See, in the beginning, I told this process is very expensive. Okay, so you have to first see what is the extent to which the soil has been contaminated, soil or water, whether it will affect the people or not. If you find you need to go for some treatment methods, then you have to decide what kind of contaminant it has. So depending on what kind of contaminant it has, you have to go for the method. If the soil is contaminated, you have to go for soil washing or electrokinematic remediation. Suppose if you have volatile organic contaminant, in that case you have to go for soil vapor extraction techniques. So depending on your soil type, depending on your contaminant type, you have to go for different techniques, and by that the cost will be different.
Okay.
So
sir.
there is no general solution for one problem. So there are different techniques based on contaminant type, soil type, or extent to which it has been contaminated. It can be used.
Sir, does the bioremediation method will work for soil contaminated by leachates?
Bioremediation, if it's
Method will work for soil contaminated by leachates.
As I told you, if there is organic contaminant, that can be used. So leachate sometimes contain some organic contaminants also, so that can be used. So leachate will be containing organic contaminants as well as heavy metals. So I think that can be used.
Sir, in this another question, sir, in the same field, can we use both surface and subsurface drain? Can it will be economical? In the same field, there will be surface drain and the subsurface drain, both.
So exactly what is the meaning of surface drain? It's a different. Subsurface drain generally we provide below the groundwater, sir, below the soil strata, buried inside, such that it can take out the water table. Are you getting my point? Groundwater drain. Surface drain means it will only remove the surface water. But here in subsurface drain, the main purpose was to reduce or decrease the water table depth such that the water will not come in contact with contaminants. So surface drain is different and subsurface drain is different.
Okay. So thank you, sir, giving a nice lecture.
Thanks.
And clearing all doubts made by the participants. Sir, only 5 minutes stay with us.
Okay.
Today is the actually last session. Validator function will be here, and our HOD will join. So just stay with us.
Okay.
So dear, 1 minute. Pratik, come online. Pratik, Pratik. Okay. Tejas sir, please come online. Mr. Tejas, come online. Okay. Okay. Our HOD will join shortly actually. So we will start the program. Okay. So thank you, Anil Kumra Mishra sir. And now I would like to thank our director, Dr. Satyavata Mohanto, and our HOD, Dr. Tushar Kumar Nath, for giving permission to organize a webinar on research and practices in civil engineering. Also, I am thankful to all the participants for your patience hearing, and I hope all of you enjoyed all the sessions of the webinar, and it may be helpful to you for future perspective. And now with us, one of our participants is with us, Mr. Tejas. So I would like to request Mr. Tejas to give feedback. Actually, students are filling the feedback form in Google Sheet, but online feedback, direct face-to-face interaction will help us to further development in future if we will organize same type of a workshop, FDP or webinar in future. So Mr. Tejas, please say some words.
Thank you, sir. Thank you, Sujit sir. I'm very pleased to be the part of this workshop RPCE 2020. I'm thankful to Civil Engineering Department, IGIT Sarang, Odisha for giving me this opportunity and organizing such an extraordinary workshop. I have seen many online workshops and I can say this was one of the best workshops with great session by some great academicians. It was really well organized workshop and happy to see immense enthusiasm from all the participants. It must be really great week for all the participants, and I wishes to IGIT Sarang team for future workshops also. And I must not forget to thank Mr. Pratik Acharya sir for his constant support throughout the week. Thank you, sir.
Okay. Now I would like to request our today's speaker, Dr. Anil Kumar Mishra sir, to say a few words to the participants, also to give some suggestion or advice to me also, me coordinator, as their participant. I want to say, outside Dr. Anil Kumar Mishra sir, he is a alumni of IGIT Sarang from 99 batch. 99 batch, sir?
99 batch, yes.
99 from Civil Engineering Department. So, as a resource person, also as an alumni, so give some suggestion or give some idea.
Yeah, it's very good to be back to IGIT because since long back I have not been there, and I'm very glad that you are organizing this webinar. Wish I could have been given more time so that I could give some more good presentation on different topics. So this is a last minute presentation. Oh, and also the questions which I got was very excellent. I mean, I'm very happy that you raised those kind of questions. But this is what I presented was a very general topic. So you need to dig more into all those topics to go, because each and every slide will be a research topic. So generally, conclude from each topic, each slide will be very difficult. But again, the questions were quite excellent, and I like your all enthusiasm for conducting all this webinar during this difficult time. So this is quite extraordinary. So I'm glad.
Sir, thank you. Okay. Thank you, sir. Actually, this is a very nice topic. Actually, participants are appreciating. Actually, in YouTube, they are commenting each and every time. Actually, you are not unable to see. Actually,
no,
so they are appreciating. This is a good topic, and yeah. That's why they are appreciating actually. This is a good, very good topic and nice presentations, and they also interested in the research in future also. They are messaging me actually.
Yeah, this is
So thank.
right now. This is a huge topic around the world. If you go any
Yeah, yeah,
part,
yeah, yeah.
US, Canada, Japan, it's a huge topic, environmental geotechnology. Because now we are more concerned about the environments. So, but at the same time, we forget our geotechnical part, because whatever contaminant gets polluted goes through the soil. So we need to treat
Okay.
it all together. It's not separate, and it's huge research topic.
Okay, okay, sir. Thank you, sir.
Okay.
Now I would like to request Mr. Pratik Acharya, who helped me a lot, starting from the website design or all other internet related things. Uh, Actually, he's behind all the works related to webinar. So I would like to request Pratik Acharya to give a vote of thanks, because actually, sir, due to some problem, I think he is unable to join. So I request Mr. Pratik to give a vote of thanks.
Thank you, sir. So I would like to thank Dr. Anil Kumar Misra sir. He accepted our invitation in a short span of time, and really we are thankful to Dr. Anil Kumar Misra sir. And I would like to thank the head of the Department of Civil Engineering, who is not right over present now due to some problem, but he has continuously support during this webinar. Then I would like to thank the Teqip coordinator, Dr. Rabindra Kumar Behra. He also not present due to some problem, but he has also provided tremendous support during this webinar. Finally, last but not the least, I would like to thank the coordinator of this program, Mr. Sujit Kumar Pradhan sir, who has initiated this program and who always come up with this kind of program in our department. He is very enthusiastic, and thank you, sir, for this.
Okay. Dear
Sir, voice
participants,
clear होनी sir.
For each organization and any other data. Okay, the net is slow. So, dear participants, for you declare that one. You declare actually some net problem is there. Okay. So, dear participants, for regarding e-certificate, we will send a link to your personal email ID. Just fill your name and organization or designation and send back to me. Okay. Then you will receive a certificate in 1 or 2 days. So thank you, sir, all the participants, and thank you joining us for 5 days. Thank you. Okay, Pratik, conclude. Thank you, Anil. Okay, okay. Okay, thank you, sir. Yes. Thank you.